Okay, day 3 of semester test review, starting with proportions. When we have an equal sign in between two fractions, what property or what system do we want to use to solve?
Fish.
What is it called? Cross multiply. Okay, we're going to take 3 times p, and we get 3p. And then we take 7 times 9, which equals 63. Last step on these would be to what? Divide by 3. P equals 21. On 66, it might look a little different. Okay, what do we have to be careful with? We have to be careful with that m plus 2. Put that in parentheses right away. Put that part in parentheses. Still cross multiplying. So we take 4 times m plus 2. 4 times m plus 2. Keep that in parentheses. And then we have equals 10 times 10. 100. Now, next step to solve is what? Distribute. So we have 4m plus 8 equals 100. Next. Subtract 8 on both sides. So we have 4m equals 100. Nope, sorry, 92. Divide by 4. What do we get?
13.
M equals 23. On 68, last one. What do we got to do? Sorry, I can back up. What do we got to do? What do we need to be careful with? That a plus 5. Put that in parentheses. So we take a times 7, 7a, equals 2 times the quantity a plus 5. What's my next step? Solve, so we need to distribute. 2 times a, 2a, 2 times 5, 10. Panic, we have a's on both sides. What do I gotta do? I gotta get them all on one side, so I'm gonna subtract 2a. So I have 5a equals 10. Last step, divide by 5. A equals 2. Any questions with solving proportions? Just remember, cross, multiply. And if you have a quantity, make sure it stays in parentheses. And then you got to distribute. Okay? Moving on to finding percent of change, stating if it's increased or decreased. So on 70, we're going from 12 to 15. So we want to find the amount of change. But we have to be careful. 12 minus 15, we're getting negative 3. So is this going to be an increase or decrease? Yep, I don't know why I wrote it like that. Back up. I read it wrong. So find the difference. Always take the bigger number minus the smaller number. And then you're going from 12 to that 15. So that is an increase. Okay, now we actually have to find the percentage. Do we remember how to set that up?
No.
Amount of change. So maybe we should write this down. Do the amount, the change over the original. So change we just found was 3. What was the original?
15? 12.
12, because we're going from 12 to 15. Then you want to divide those. What's 3 divided by 12? 3 divided by 12.
4.
3 divided by
3 divided by 12.
0.25.
0.25. Can we leave it like that? Because it wants percentage.
25%.
Yep, so we need to multiply by 100 to get us 25%. On 72, we're going from 74 to 44. What is the first thing we got to find? We got to find the change. So subtract the two numbers. 74 minus 44 is 30. And then is it increase or decrease? Decrease because we're going down. And then how do we find the percentage? So the change over the original, which is 74. What do you get when you divide those? 30 divided by 74.
Yeah.
0.485?
Yeah. 05.
405?
Yeah.
And I can't leave it like that, so what do I have to do?
41%.
Multiply it by 100, so you get about 40.5%.
I said 41%.
That's okay.
How,
So just remember, change over the original. Okay. 70, we're going from 12 to 15, so we're going up. On 72, we're going from 74 to 44, so we're going down.
Okay, so
Yeah, go for it.
does it matter which?
We talked about the constant of variation. What is the constant of variation the same thing as? It's the same thing as, starts with the S. Going up or down? Slope. Constant of variation is the same thing as a slope. So what's the slope or constant of variation of 74? 74. 7 over 10. Same thing. Constant variation and slope are the same thing. Okay? Working with direct variation, we just said that it's basically the same thing as slope, right? Remember y equals k times x? I'll write that down. Y equals k times x. We're going to use that equation to help us solve these problems. So if y varies directly as x, y is 4 and x is 8. We need to use those to find what k is. So how do I do that? I'm going to plug them in, right?
Yeah.
Y said was 4.
you're on odds again.
Oh, sorry. Thank you. Sorry. 76. We're the same thing. We're still using this formula. Y is 12. What was x?
4.
And we don't know what k is. Good. We want to get k by itself. What do I need to do? Divide by 4. So we get k is equal to 3. Now, don't stop there because that's not my final answer. What is it asking us for?
Find y.
We want to find y when x equals 7. We're going to use that same equation, but now we have our k. So we're looking for y, and we know k is 3 and x is 7. So what is y? 21. So you're going to use, on these problems, you're going to use that equation 2 different times. Okay, any questions on those? So I used it once here, twice here. Okay? All right, absolute values. We just got done doing absolute values with inequalities. Do you remember how to do them with equal signs?
2 cases.
2 cases. On 78, what would case 1 be? Yep, case 1 always stays the same. What would case 2 be? V equals -2. What's the only thing that changes? The sign of, yep, the side of the equal sign without the absolute value. Just changes to a negative. Yeah. Okay, on those, do we have to do anything?
No.
No, it's already by itself.
Freebie.
On 80, that is a freebie. On 80, what would case 1 be?
R over 80.
Yep, keep it the same. And then what would case 2 be?
R over 80
Equals -4. So we have to solve both of those. How would I solve both of those?
times by 8.
Multiply by 8 on both sides. So for case 1, I get R is 32. For case 2, I get R is -32. Okay, last one. What would case 1 be?
8x minus 4.
Yep. Keep it the same. Case 2.
8x minus 4 equals -36.
Does the absolute value ever change? No. Absolute value will never change with equations or inequalities. Solving on case 1, what I do? Add 4. So we have 8x equals 40. Last step.
Oh,
Divide by 8, x equals 5. Don't forget to go back and do case 2. Case 2, we have to add 4. What do I get when I add 4 to negative 36? Negative 32. Divide by 8. And get x equals negative 4. So every time, whenever I get case 1, can I assume that it's case 2 is the negative of that answer? No, never assume that, okay? Questions on that page right there? All right. Moving on. Do we remember these?
Yeah.
Okay. What helps us solve these problems?
The cups, like the little cup.
Yep, the cups. We have cup 1, cup 2, and then our final cup. Let's talk about this. What's happening between the top 2 cups when they go into the mixture? They're adding. So what's happening in the cups? What operation? Inside the individual cups, what operation is happening? Multiplication, yep. So I'm just going to put an X on the outside so we remember. Okay, says Maria wants to make 55% acid solution. She has already poured 2 quarts of a 25% acid solution into the beaker. How many quarts of a 75% acid solution must be added to this to create the desired mixture? Okay. Yep. So that 2 quarts is on the top. What do we have to do with those percentages?
Oh, I'll put them as decimal.
Put them as decimals, so that would be 0.25, right? That's cup 1. What about cup 2?
1. Wait. X.
We don't know how many quarts, right? And then what was the percentage? 75, so we need to do 0.75. And then, what do we put on the bottom? Yep, 2 plus x. And then we have 0.55. Is there any questions on how we set that up right there?
No.
Okay, just making sure you read everything carefully and what goes with what. Okay, and remember, you're adding the 2 top ones to the bottom one. That's why we have that 2 plus x. Now, how do we set this up? So we're going to set it up. We're going to take 2 times 0.25 plus, so that was beaker 1, plus 0.75 times x, that was beaker 2, equals 0.55 times 2 plus x. Now, do you remember what we did to every single one?
Multiply by 100.
Multiply by 100. Awesome. Multiply each term by 100. What are we going to get for the first one? What?
25. For the first one?
Yep, we're going to get 200 times 0.25 plus 75x equals 55 times 2 plus x. Are you whatting because of this?
Yeah.
If you multiplied the 100 by the 25, you'll get the same thing. Okay? Doesn't matter which one you do. That's fine. Now, keep simplifying. 200 times 0.25. 200 times 0.25 is 50. Plus 75x. What do I have to do on that right side? I have to distribute 55 times 2.
You said times 2.5, right?
Yeah. What?
500. 2 times.
200 times 0.25.
Oh, 0.25. I think you said 2.
That's okay. And then 55 times x plus 55x. Are we all good here?
Yeah.
Okay. Underline like terms. We want all the x's on one side. What should I do?
Subtract the 75.
You want to subtract 75 over?
Well,
We can. Subtract 75x on both sides. I'm going to come down here. So we have 50 equals 110 plus, minus 20x. Next step would be to subtract 110. What's 50 minus 110?
Negative 60.
Negative 60 equals negative 20x. Last step, divide by negative 20, and we get 3. That is your final answer. Okay. Long process, yes, but is it difficult? It just has a lot of steps to it, right? Biggest thing, did you understand how to set up our picture?
yes.
Okay. So after you set up your picture, remember the individual boxes are multiplying. And then you're adding the 2 boxes to equal your mixture. Okay. Yeah.
Subtracted 50, would it be the same?
Yes, if you did it the opposite way, it would be the same. Yep. All right, let's set up 86. Says Jennifer wants to make 20 gallons of a 57% acid solution by mixing together 30% acid solution and a 90% acid solution. How much of each acid solution must be used? Draw a picture. Remember, we're adding. She wants to make 20 gallons of a 57% acid solution. We have to have 20 gallons down here of a 57% acid solution. So we want that 57 down here, right?
And the salsa cups. I put it the other way around.
X. We don't know either of those.
So it's just
Okay.
20x.
Let's just talk about setting this up. We're not going to go through and solve. We're just going to set it up. How would I set it up?
30 times x.
Yep, 0.30 times x plus,
0.90 times x.
yep,
Equals 20 times 0.57.
awesome. Does everyone understand why we set it up that way? You don't? Okay, so I'm taking box 1 and I'm multiplying the components of box 1. Taking box 2, and then I'm adding because we have this addition here. Taking components of box 2, multiplying them together. And then equals the components of box C multiplied together. Does that make more sense? Yeah. And then, I'm not going to do it with you, but what would your next step be here? You could add like terms. What do you want to do first? Multiply it by 100 first.
What, all of them?
Okay, all of them. Every single one. Okay? Questions on those? If we need to come back to those on Monday, we will.
So wouldn't it be,
Last ones we got to go over are algebraic expressions. It gives us an equation. We want to solve for A. What does it mean solving for A? Get A by itself. What would our first step be?
Multiply everything by A.
Yep, we want to get rid of that fraction. Multiply everything by A. So on the left, I get AZ equals M.
then you divide by some.
Yep, get A by itself. We want to divide by Z. So we get A equals M divided by Z. Are we done?
Yeah.
Yes, because A is by itself. Last one, right? Again, we want to get A by itself. What would my first step be? Add B. What do I have on my left side? Z plus B equals AM. So don't forget, if you add B, you're adding it to the other side. Z doesn't just go away. Okay, you still have that Z plus B. No letter is ever going to go away. The letters you start with are the letters you end with. And then we
Divide by n.
divide by m, so we get a equals, and then just leave that as one big fraction. So the letters you start with are the letters you end with. All of them. They don't go away. I feel like we went over a lot today. Do we have any questions? We're good?
Yeah.
All right. Nice job.